Hello, today we are going to install and use the operating system 9front, which is similar to the operating system Plan9 from Bell Labs. We go to derivatives and forks, and it's the third one in here, 9front. Says that they have a release available named Do Not Install. And that there is support for AMD64. I will install in a QEMU virtual manager virtual machine. This is the file that I need, the ISO for AMD64, and it's available via BitTorrent. I have downloaded the ISO file. Now let's install inside Virt Manager. File, new virtual machine, ISO, browse, 9front. Could not detect a template for the virtual machine. Let's select something. I don't know exactly what I want to select in here. Let's go with an old BSD and see if we can upgrade from there. So this is a distributed operating system, last released this year. So I'm going to guess it knows at least 10 gigabytes of RAM. Hopefully it knows more than 4 vCPU. So let's go with 8. And if it says that it supports ext2, ext4, USB audio, Raspberry Pi, hopefully it also knows the Virt.io drivers. So the name of the operating system is 9front. I'm going to go with a newer motherboard. Hopefully they have support for QEMU. I would guess that they developed the operating system on Linux and then they develop it in QEMU. So hopefully it has support for the latest and greatest virtual hard disk technology and network interface card, which is offered by QEMU. So the disk, they probably know SATA. Let's try Virt.io straight. And SATA. And in here we'll also go with Virt.io. If we fail to boot like this, we'll go one level below, which is E1000 for network interface card and SATA for the virtual hard disk. And maybe it also knows USB graphics tablet. We'll find out soon enough. So it's creating a virtual hard disk and it manages to boot from the CD-ROM, so SATA. The bootloader does not auto-boot, it waits for user input. I'm going to press enter. User Glenda, so this is kind of like a first boot wizard. Do we have bigger than 1024 by 768? That would be a nice thing to have. I don't know what is the actual resolution that I want. So maybe 1024 3 by 4 aspect ratio. Let's see if we can specify almost any resolution and bit depth in here. So I went with 4 by 3 and aspect ratio and this resolution here. 1280 by 1024. Monitor. What's the difference between an LCD and VESA? It booted instantly in graphics mode. It didn't actually boot, it just switched from text user interface mode to graphical user interface mode, but still inside the equivalent of a TTUI. So we're still at the console, and the first run wizard continues with the questions. So it says if I want PS2 mouse, and I'm going to go with yes. How do I do that? Okay. So now it finished booting. I have a terminal. I have a window manager. I can resize the window with all of the edges and all of the corners. Okay. The terminal is running a command line shell, which is probably RC, but I'm in a completely alien environment. I do not know how to start graphical user interface apps, and the operating system, being Plan9 based, doesn't really have many of the command line applications that I would expect in a minimal Unix userland. So it does have a PS. There's no pager in here. Instead, you scroll with the mouse. So let's see what we have in here. The PS command line executable or built-in. We have RC, which I'm going to guess it's the command line shell. Rio, which is part of the graphical user interface, I'm going to guess. Maybe the equivalent of the X server of the window manager. Keyboard file system translator. These things also probably KB. DNS might be, I don't know, a DNS client. So I'm totally alien and lost in here. I managed to find a command line executable that makes sense to exist in a minimal Unix userland. So that was PS. Let's see how we get to the help. Not like this. Up arrow doesn't really go through the history. It scrolls the graphical user interface terminal up and down. Yes, -H. Help. Yes. Yes, AUX is the exact same output. Okay, let's see W. Who am I? So the first run wizard asked me if I want a local Plan9 user to be created, which is called Glenda, and I said yes. Probably in there you can enter another name for your local user. Which? Nope. Set echo. Echo works. So I found PS, who, and echo until now. Would be nice to have a text user interface file manager. I'm not sure what MC is, but doesn't look like midnight commander. How do we stop processes? Control C does not work. Control V. Exit. Again, totally alien. I searched on Google for the Plan9 equivalent of sending a Control C, and I got to this page, which says Unix to Plan9 command translation. In here I can find that Control C is the delete key. So I have a Windows style keyboard. I have a delete key, a backspace key. So that worked. I pressed the delete key and it closed MC, whatever MC is. The home of Glenda, PWD, another executable that exists. Let me actually write down all of the executables that I found until now. Yes, who, echo, and PWD. Okay, I have also seen ls work. So ls slash paths seem to start from slash. Paths are slash separated. They prefer all lowercase, so similar to Unix in this regard. And with pwd, I can see that I'm in my home directory, which is /usr/glenda. There's no /home directory. Glenda is the name of my user. Let's see if there's a list of executables. I'm pressing tab twice, doesn't do auto-completion of all of the possible executables. So I have /usr. There's directories which are specific to a CPU ISA architecture. So there's Intel 386, Intel AMD 64, EMT 64, x86 64, this one. There's ARM 32-bit and ARM 64-bit. There's Motorola MK68000. Probably this thing is also an advancement from that, so 68020. There's Intel Power 32-bit and Intel Power 64-bit. There's Sun Spark 32-bit and Sun Spark 64-bit. So these two ISAs from 68,000 and the Sparks are really old architectures. A thing that Plan9 tries to do is to be as portable as possible and installed on multiple computers. It's a distributed operating system running on multiple computers at the same time. And they also want to be able to run, I don't know, on 3 different computers at the same time, where 2 are AMD 64 and 1 is ARM 64. So even the ISA CPU instruction set architecture might be different between the computers that make up between the hardware computers that make up the distributed computer operating system instance. And they have a simple C programming language compiler, which is they wrote from scratch, and it has tool chains for building executables for all of these ISAs by default. Let's see that. So ls/usr. What is it doing? ls/lists the contents of the directory slash, and ls/usr/ just says that I'm in the home directory. Maybe there's just one directory in /usr. Okay. Then maybe usr is for actual users. There's a sys directory in here. Okay, there's a C include for header file C style probably. Where are the actual AMD64 specific executables though? How about the /AMD64? No auto-completion on pressing the tab key. Okay, AMD60. So it writes at random places where the cursor is. Okay, so get the cursor back. Let's see what's in here. So there's a bin directory. How do we copy paste? Drag and drop. ls/amd 64/bin. Okay, so the short binary names with numbers in them, if I remember correctly, are the CPU ISA architecture. So there's a C, an L, A. So just going to blindly guess here, there's the CPU architecture one. I'm not sure which one is, and this is probably going to be the minimal assembler executable, and this would be a compiler, C compiler, and this would be a linker. Let's actually find out the numbers. I searched for what is bin/1c. For Plan9, I got to this web page, lysator.lu.se, which I have seen before. Maybe it's a, I don't know, university in Sweden. And Plan9, article written by Rob, Plan9's Rob. And in here it says how the Plan9 team views the C compiler. So there's one compiler for each of the supported architectures, accepts a dialect of ANSI C. There's also a C compiler that's used for porting POSIX source code. There's if def include, no if, and just one single pragma. They want to have the C compiler source code be as human readable as possible, so the number of lines in the C programming language compiler source code needs to be as short as possible. The source code must be easily understandable, but still it must output efficient, optimized binary executables for the target CPU, Central Processing Unit, ISA. There's a /mips include. Machine independent includes are in /c/include, so the equivalent of a no-arch Linux package, whereas /mips/include is machine specific. Every Plan9 program, C program starts with include u.h. Okay. And scrolling down, we get to the names. So it says that each CPU architecture supported by Plan9 has a single arbitrary alphanumeric character. V is MIPS. We don't have V. Or do we? Where was it? When we listed slash. No. MIPS. There is. Probably 32-bit little endian. Who knows what MIPS might stand for. So there's a V for MIPS, K for Spark, Z for Hobbit, 2 for the Motorolas, 8 for Intel 32-bit. There's even a 6 for Intel 960. So Motorola 68020 is the C compiler 2C, assembler 2A, and linker 2L. And object files are suffixed by a .2. So when you compile a translation unit, a C file, you get as output a 2.out binary object file for this Motorola 68020. And then it goes on with examples for this architecture. So a source code file named file.c with contents one of these. Let's say this print hello world, the simplest one, which starts with include u.h and says print, which print is a C programming language statement. There's printf, but print, I don't know. And \n, which is escaped. It's interesting. They have a printf, which probably is stdio. Okay, so 2C, the C compiler, which was written from scratch by the Plan9 team in order to be two things: the core of the operating system, because the rest of the operating system is probably major parts of it, the kernel including, is written in this special dialect of the C programming language. The C compiler needs to be portable to all of the CPU architectures which are supported out of the box by Plan9 operating system. And also the source code of the compiler needs to be extremely grabbable and easy to understand and keep in one person's head. There's an MK which is equivalent to GNU make. Okay. And then you link the .o file, .out file, not. So 2L is the linker, file.2 is the .o file, so the object file. This is the source code. This is the output of compiling the translation unit and linking it, which is strange. Oh yeah, so compiling generates a file with extension .2, and then linking the thing results in the default executable name, which is out, but not a.out, but 2.out because of the architecture that we're specifying here in the name of the linker. And it says that you can just run the executable without specifying a full path or a relative path, so no need for ./2.out. I would do these examples, but then I do not know how to create a file. MK is a descendant of make. /mip/make file. Okay, let's look at that file. So how do we list file contents? There's probably a cat, delete. So ls/amd64. There's a mc file. I do not know which one is a directory, which one is a file. The scroll is too powerful. It scrolls half of a screen at once, so similar to, I know, Emacs. Just moving the wheel of my mouse once advances half of a screen. Okay, let's see what it says in here. That inside /amd64 or /mips or another directory which is specific per CPU architecture, there's a file named mk file, which is related to mk executable, which is probably a source code file for the mk executable to run, similar to make file. We can see that the compiler is 6C, so I'm going to guess that 6 is AMD64. Let's see 32-bit 386, what number does it have? So it says 8 is Intel 386. So hopefully 6 is AMD64. It's interesting the way the numbers and letter are assigned, because hopefully the architecture 8 came way before the architecture AMD64. I know AMD64 was invented in what, 2003. Okay, so there's a CC environment variable, which is similar to what you would expect in Unix, which is the C compiler. LD is the linker. Oh, I'm not sure what it is. The suffix for object files. So object files, instead of ending with .o, end with .6. AS is the assembler 6A. And maybe the rest are not CPU specific and are taken from this include /c/src/makefile.proto. This one, RL, probably is defined there. Let's actually check. Common environment variables or makefile parameters shared by the rest of the architectures. In here you can say that you don't want support for all CPUs when you're building executables, or maybe the kernel, or the Plan9 system from source code. There's a lex and a yak. MK is in /bin. What is /bin? Let's see what /bin is. So there indeed is a /bin, and there's no /sys/bin. What does that mean? Maybe it's a symlink to /amd64/bin. So double quotes 0A, 1A, 2C. Let's see the output of that. /amd64/bin. The output is different, so not a symlink. Maybe an overlay or something. There's no 0A in there. So in /bin there's a 0A, 0C, 0L, and then these two executables with double quote and a pair of double quotes. 0, 1, 2, 5, 6, 7, 8. And then the others. Can I see the other three? So I am looking for a tuple, 3 executables with 2 names, 2 characters in the executable name, and the first character is identical. There's a C, there's an A, and there's an L, so there's a architecture V. I can see RM, SHA1 sum, RC, which is probably the command line executable. I can see the architecture Q, QA, QC, QL. This will probably not go down well. So I searched on Google Plan9 command line text editor. The text editor is graphical user interface mode, not command line. It's acme or SAM. Acme or Sam, who knows. Some instructions are about Sam, the Rob's text editor. And then there's instructions about acme. I have seen that the command line executable touch exists, so let's try to write some code without copy paste, because we can't run web browsers inside the operating system 9front, and because I don't know how to connect to 9front using telnet or SSH or remote desktop protocol or VNC, etc. So I do not know a ton of the things which might be possible under 9front or which are just not possible under 9front. I guess a possibility is to download the contents of a page using something similar to wget or curl. So we'll see. Where am I? In my home directory. How do I create directories? I don't know. How do I create files? ls/usr/lambda. A bin, a lib, and a tmp directory. Okay. Touch hello.c. Can't create files. Now that I think about it, we didn't really install the operating system at all. We just presented a ISO file to the virtual machine, and now it's just ignoring the hard disk. It's ignoring this thing and running exclusively from this thing. So maybe that's why the file systems are read only. We need to find a way to actually install this live system to the 200 gigabytes, or what was it? Vert.io hard disk. Okay. Does CD work? Is this tilde/tmp directory read-write? Nope. Let's just start acme. So these are some of the executables which are provided. We have acme, which is a text editor and more. And then there's the terminal that we had previously. I do not know how to move files around, or how to move windows around. Says that I need button 3 to move the window. So they say with button 1 or 2 I can resize like this and like this and like this. So button 2 would be the scroll wheel. Button 1 would be the left mouse button. And with the right mouse button, I'm allowed to move the window around. But to my surprise, there's no terminal anymore. Maybe the terminal turned into this graphical user interface application. How do I select to exit? And now I'm back to the terminal. Let's make the terminal really small. Move it around and then start Acme here. Okay, so the graphical user interface terminal window becomes the text editor's graphical user interface applications window, or maybe there's more nuances to the graphical user interface applications. Maybe this is a mix of a text user interface application and a graphical user interface application. It certainly behaves like a text user interface application in the sense that the newly started text editor behaves like, I know, Emacs VI. It stays put inside of the confines of the terminal graphical user interface window. So I wanted to exit. I pressed the left mouse button, middle mouse button, and that was it. So button 3, middle mouse button, the scroll wheel, clicking with the scroll wheel performs the action. So this is the left mouse button action, moves the cursor around. Right mouse button is about resizing and moving and exiting, kind of like a context menu for the current application. And then middle click mouse, so clicking on the scroll wheel, is probably trying to do an action with the word acme. Let's see what cut does. Cut is probably copy, paste. Cut is really cut. Yay, we have copy paste working. We have cut paste working. Not sure how we actually copy without cutting. So the previous output of the terminal is actually editable. As we saw, you can put the cursor wherever you want. You can write, you can delete, you can cut. Control X U. Control X U does work. Okay, that's interesting. Control L does not, to clear the terminal. So until now I found only two more than text user interface applications. That's the terminal and the text editor Acme. Let's see what SAM is. SAM is also something that's more than a text user interface app. Need to open it by specifying files. Text, I'm writing text. Okay, and now I have a second buffer. Three graphical user interface applications, the terminal, SAM, and Acme. There's a ton of reading to do if you want to start surviving inside the Plan9 operating system or inside this operating system 9front, which is extremely similar, kind of like a distribution, a mini fork of Plan9, 9front. Rio is the the desktop environment, web, the desktop background, the file manager, the Windows server, so similar to X11 Wayland. Says that you have a mouse with 3 buttons, no context menu, nothing happens if you click on the background with the left mouse button. Then mouse button 2, which is middle click, which is clicking on the scroll wheel. Nothing happens. Whereas button 3 creates a context menu like this. New, resize, move, delete, hide, exit. New. The cursor changes to a cross. And then we want to create a rectangle with button 3. A new window is created, and the window contains the RC shell. Oh. Can we start RC here? I don't know how to do that, but maybe. The context menu appears on mouse down and disappears on mouse up. So you need to keep the right mouse button pressed a ton of time until you decide and you get to actually be able to read what the context menu says, because you cannot see by default because the cursor is so huge. You need to move a bit and see, oh, that's new in there, and it's not nothing. Okay, new, resize, move, delete, hide. And then again, right mouse button click. So it's hidden somewhere. Where? So, what is that? Add battery.